Hello, this is Miss Jackson. I'm going to make a video to cover the last 4 or 5 problems on the Unit 3 test review. It starts with problems 9 and 10. They're part of a joint question. We haven't looked at these too much. We're just starting to work on them, and this setup will not show up on the test. But it's still good to go over, and the ideas will show up on the test. Okay, it says this question has 2 parts. Terry's pumpkin patch is represented in the model below. This is an array. Arrays are set up in equal rows, and each row has the exact same amount in them. The first thing I'm going to do is set up the multiplication problem that represents this row, or this array. I see that there are 1, 2, 3, 4 rows. That's my first factor. Times, the second factor is going to be how many objects are in each row, or the number of columns. 1, 2, 3, 4, 5. From there it says, how many rows of pumpkins did Terry plant and how many pumpkins were in each row? Complete the sentence by selecting the correct answer. So let's work through this together. Right here's the sentence. Terry planted, and then there's just a random number 9 there. You're going to find your answer here for question number 9, and that's what that means. Terry planted blank rows of pumpkins. Well, we already wrote our multiplication sentence, and we said there are 4 rows of pumpkins. So I'm going to select B. Terry planted 4 rows of pumpkins with blank. There's a number 10. That means our answer is going to come from number 10, pumpkins in each row. Well, we've already looked at our array, and we said that there were 5 pumpkins in each row, so we'll select D. If we were to plug these numbers into the sentence, it would say Terry planted 4 rows of pumpkins with 5 pumpkins in each row. Moving on to question 11. It says Albert listed different models he thinks he can use to solve the multiplication problem shown below. And here is our problem, 4 times 3. Which of these is not a method he can use to solve the problem? So we're going to look for one thing that does not represent 4 times 3. So let's go one at a time. Answer choice A says 4 plus 4 plus 4 plus 4. We have the number 4 being added 4 times. Well, if we look back at our problem, we should have the number 4 added 3 times. So this does not represent 4 times 3. This could be our answer choice. It certainly is one that doesn't represent that, but let's check everything else just to be sure. Problem B is a number line, and on this number line, it's skip counting by the same number over and over. That is a multiplication number line because the number is increasing the entire time. Here, based on the problem 4 times 3, we should have 4 hops of 3. Well, I'm going to count my hops first. 1, 2, 3, 4. That's correct. And let's see the length of each hop. That's a distance of 3. That's a distance of 3, 3, and 3. This does represent the problem correctly, so that cannot be the correct answer here. We want the one that does not show it correctly. Option C is skip counting. We can skip count by 2 different numbers here. We can skip count by 3s or 4s because those are our factors. If we skip count by the number 3, we're going to do it 4 times, and we would say 3, 6, 9, 12. So that does represent the problem. That can't be the correct answer. The last model is an array. If we remember, our problem is 4 times 3. 4 should be the number of rows, and I see 1, 2, 3, 4. 3 should be the number of columns. 1, 2, 3. This represents the problem. That means it cannot be the correct answer. We want the one that does not represent the problem. Well, the only answer choice we have is A. It has 1 4 too many to represent our problem correctly. Moving on, we have 2 problems left, 12 and 13. 12 says, the model shown can be represented using 2 different number sentences. And here's our model. It's soccer ball set up in an array. Which 2 number sentences can the model represent? Well, the first number sentence I'm going to look for is a multiplication number sentence. To write a multiplication number sentence for an array, we need the number of rows multiplied by the number of columns. That's going to look like 1, 2, 3 times 1, 2, 3, 4, 5. Ooh, let's see if we can make it before that dies. 3 times 5 is going to be our multiplication sentence. Let's see if we can find that anywhere. I see 5 times 3. That would work also because our factors can switch places. So far this is okay. And then the other option on A is 5 plus 3. Well, 5 plus 3 is only 8, and I know that if I add up all of the soccer balls here, I have a total of 15. So this is not correct. B, 5 times 5. Well, if I multiply 5 times 5, I'm going to come up with 25. That's way too many soccer balls to represent this array. That is not correct. Answer choice C. Part 1 is 3 times 5, and that works. Part 2 is 5 plus 5 plus 5. Let's see if that's correct. I have 5 soccer balls here, 5 here, and 5 here. I could add those together in a repeated addition sentence and come up with the total 15. So that does work. Let's check answer choice D next. It says 5 times 3, and technically that could work because our factors can switch spots and we come up with the same answer. But if you look at the second part of it, 5 times 5 times 5, that is going to give us a number that is way greater than 15 soccer balls. So that cannot be the correct answer. So D is out. That only leaves us with C. Please, all my sweet little friends out there, if you're listening to this, look very carefully at the operations because they're going to try to trick you with that. If you see this, that is not the same as this. Okay, 5 times 5 times 5 is going to give us a much greater number than 5 plus 5 plus 5. Please be very, 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 very careful, and then be careful another time just for the fun of it. Okay, last problem, problem 13. Avery runs 10 miles each day while training for a marathon. How many miles will she run after 9 days? We can draw a model to represent this. I know she's running a total of 9 days, so I'm going to start with 9 groups. One, 2, 3, 4, 5, 6, 7, 8, 9. Every one of these she runs 10 miles. Okay, let's set up a multiplication sentence for this first. 9 groups of 10, or 9 days of 10 miles equals some number. I love when 10 is a factor because we get to skip count by 10, and we are so good at that. We are going to skip count by 10 9 times. 10, 20, 30, 40, 50, 60, 70, 80, 90. She's going to run a total of 90 miles. Answer choice B. When our factors, one of our factors, if we have a factor of a 2, a 5, or a 10, that is the number we want to skip count by. We just want to skip count however many times the other factor tells us to because we're really good at skip counting by 2s and 5s and 10s. They've done it for years. They're very successful with that. Even if my problem had been set up 10 times 9 for some reason, I'm not counting 9 10 times. No way. I'm going to count 10 9 times. And I can do that because factors can move into either spot and we're going to still come up with the same product. Okay, that is everything for this video. If you have any questions, please feel free to reach out to me. I will be happy to help you. Thank you for watching.